Okay, so in this video, I'm just going to give you idea of how to do assignment 7. Again, I don't want to go into the details because that will be kind of explaining the whole algorithm, which is something that you are supposed to come up for this assignment. Um, so we are going to use a stack to do a pre-ordered traversal of a binary tree. So let us take up this binary tree here. So a stack, again, will operate in lost in first out fashion. So we're going to use the stack to store the node IDs that are supposed to be visited or traversed. Okay. So we start with by pushing the root node ID 0 to the stack. Okay. And then you go through a series of iterations and you run the iterations until the stack becomes empty. So that means you're going to run the iterations as long as the stack is not empty. So in each iteration you will be popping the stack, that means the node ID that is in the top of the stack will come out of the stack. So when the node ID that comes out of this, when the node ID that comes out of the stack, that is being popped out of the stack, is considered to be visited. Okay, so the moment you pop that node ID from the stack, that's the moment you consider that node to be visited. Okay. So now again in each iteration you pop the stack, and so one node ID comes out of the stack, and after popping out that node ID you try to visit its child nodes. So you will be adding the child node IDs to the stack. Again, this is a binary tree, so you have a left child and right child. And we want to do a pre-ordered traversal here. So pre-ordered traversal, the policy is root, left, right. So you should be adding the two child nodes in such a way that the left child will be visited after this node and not the right child. Okay, so I leave it up to you to figure out in what order you should push the left child ID and right child ID to the stack. So to begin with, the stack has node 0, so you start the iterations. In the first iteration, 0 is popped out of the stack, so node 0 is considered to be visited. So now you should be adding the two child node IDs 1 and 2 to the stack in such a way that node ID 1 is in the top of the stack and node ID 2, which is the right child, is in the bottom of the stack. So that's one iteration. Then continue the iterations. The stack is not empty, so you can continue the iterations and you pop the stack. So node ID 1 comes out of the stack, which is considered to be visited. So now you want to add its child nodes. There's only a left child ID, and once it's added you will be having node 3 in the top of the stack. So now the next iteration, you pop the stack, 3 comes out, it's considered to be visited, and you will be adding or pushing its child node IDs. So 6 is the only child node, so it will be now the top of the stack. So now pop the stack, 6 comes out, considered to be visited. So again, these are the nodes that are popped out of the stack. So after 6 is popped out, 2 is in the top of the stack. So now you're visiting 2. So you pop out 2. You'll be pushing its child node ID such that 4 is in the top of the stack and 5 is the right child. So 4 now is popped out of the stack, so it's considered to be visited. And then you'll be pushing its child node ID 7 and 8 such that 7 now is in the top of the stack, so you pop the stack, 7 is considered to be visited, and you push its child node ID, which is 9, and 9 is now popped out, so 9 is considered to be visited. Then 8 is in the top of the stack, it's popped out, 8 is considered to be visited, and then 5 is in the top of the stack, so it pop out 5, so 5 is considered to be visited. So this is it. Now the stack is empty. You're done. Okay. So this is a pre-order listing of the vertices in the binary tree using a stack. There's no recursion here. Okay. So this is kind of an iterative approach. Okay. So I think I've given almost the idea. So it's now up to you to figure out how to push the child nodes. That's the most critical part of this assignment. Okay. All right. So let me stop here.